This section is talking about factoring polynomials. Now we've already talked about factoring quadratics, right? So this focus is on polynomials. So basically any polynomial you're given, remember it's a monomial or a sum of monomials, you're going to need to be able to factor them completely. Now, there's not a lot that's changed as far as the steps. You will always look for a GCF first. Greatest common factor is always first. And then you count the number of terms. If you have two terms means it could be the difference of squares, that's these guys, right? Same thing, twins, but they're not identical. I don't know if that reminds you of it. You're looking for a subtract, and then you check for square roots. For example, x squared minus 49. There is a subtraction between, right? There's a minus. And if you square root both of them, square root of x squared is x, square root of 49 is 7. Twins, except they're not identical because one has a plus and one has a minus in it. So that's the difference of perfect squares. Remember, sometimes those can go a little bit further. You might be able to factor it with a difference of squares again, so keep an eye on that. If this is a plus, it does not factor. That's when it's perfect squares. Now, a new one that we're going to learn is this one right here, the sum and difference of cubes. We'll talk about that one in this presentation. You already know difference of squares. You should be familiar with it. But the sum and difference of cubes, I'm going to show you that today. Okay, the other ones that we've already talked about are trinomials, right? 3 terms. You had the easy ones here where your a was equal to 1. It was just a simple double bubble. What two numbers multiply to this, right? The crisscross, multiply to c, but add to b. Simple. Then there was the kind that had a greater than 1. In that case, I taught you what's called a cloud. You might have had your own method, rainbow method, or whatever it is that you use, backwards box. Doesn't matter what you use, you still will just factor that out, and it'll come to binomials. Okay, this next one, though, is new. It's called quadratic in form. Basically, it factors like a quadratic. It's just going to have a couple different pieces in it, and I'm going to show you that one as well. The last thing was factoring by grouping. This is when there are 4 or more terms. Remember, you group the first 2 and the last 2. Find a GCF from each group. What a coincidence, right? They both have it. The coincidence goes out in front, and then your leftovers are what go inside there. Don't forget to look if there's a GCF. If the GCF is negative, change the signs inside. If you look back at some examples there, you'll remember that stuff. Okay, and then the last thing to remember was to check and see if your final answers factor any further. And that one is going to be huge for this section. Whoops, we don't want that ugly one. We want yellow. Yellow is so pretty. You should always check to see if it factors further. Like I said, on these difference of squares ones, let me show an example really quick of one. We had some that were, let's say, 16x to the 4th minus 1. That was a minus here, so we were able to square root both sides. Square root of 16 was 4. Square root of x to the 4th, if you think about that, that's 4 x's. Pair homies there, pair homies there. So this equals x squared. So we had 4x squared and a 1. The twins, but they don't match because one's plus and one's minus. Now what you had to do was look at this other one, this one right here, and say, wait a minute, it's subtract again, so can I factor it further? Well, is there a square root of 4x squared? Yeah, it's 2x. Is there a square root of 1? 1. Twins, but they're not identical. One's plus and one's minus. So your final answer for this guy would have been the 4x squared plus 1 and then 2x plus 1 and 2x minus 1. I'll show you some more of those towards the end though. So check to see if it factors further. This is a perfect example of it. All right, let's start with the sum and difference of cubes. This is a formula, just a formula. You just have to remember what pieces go in the formula and where, and then to do the proper operations of them. So sum and difference of cubes. Sum obviously means plus, difference means minus. This is raised to a power. That's a multiple of 3. So it could have its 6th power, right? X to the 6th would work, or just plain x to the 3rd, or x to the 12th. Any of these could be applied here because they're all multiples of 3. Okay, that's the key. This basic example is going to be with 3's, but I'll show you again how to apply these other ones as it goes. So a cube, a cubed plus b cubed. You have to figure out what a is. That's easy. You take the cubed root this time, or find a pair of 3 homies, right? And then you've got b here. That's the cubed root of b cubed. Then it's just a matter of plugging them in. You figure out what a is. You put 1 here, 1 here, 1 here. Figure out what b is. 1 goes here, here, and here. Then you've got these guys are squared on the outsides. And then right here in the middle, these get multiplied. Okay, that's the basic setup. You have to find what the cube roots are. That's your a and your b, and you just plug them into the pieces. This is the same as the beginning, except for the cubed isn't there. This first one's squared, the last one's squared, and you multiply them in the middle. Now, when it comes to the pluses and minuses, this sign right here will always be the same as what you started with. Notice down here for the difference, that guy right there was the same again. This next one over here is the opposite, right? See how it's opposite to go to there. And then the last one is always positive. Always. Looks messy because my finger keeps touching the stupid thing. So it's got all these little stray random pieces in here. We don't want those. Always positive. So SOAP is how we remember that. SOAP stands for first sign is the same as the beginning, second one's the opposite, and the last one's always positive. So the first sign, the second, and then the last is always positive. Again, this is just all about the formulas. AB, A squared, AB, B squared is how I used to say it to myself. And then apply SOAP to get your signs. Let's look at one. All right, we've got 2 terms. This is how you walk through it. First thing I'm going to look for is a GCF. There is no GCF here. This is X's and this is 27. There's no X's involved and no numbers. So I'm going to count the number of terms. There are 2 terms and there's a subtract in between, so it's a minus. First thing I would look for then is a perfect square. Well, is there a square root of x cubed? So these are the answers I'm asking, or sorry, the questions I'm asking myself as I'm working through here. Well, it's x cubed, so it's not a perfect square. Is it a perfect cube? Okay, let's look at this. Is it a perfect cube? If it is, that means that I can take the cubed root of both of them and find the cubed root of it. So this one, cubed root of x cubed, well, cubed root, x cubed is x times x times x. We've got a group of homies there, right? 3 is our size. 2 of them die this time, and just 1 makes it out. So this guy would be an x. What about 27? Well, if you break down 27, that is 9 and 3, 3 and 3. So altogether it's 3, 3, and 3. Got a group. Two of the homies die because one only ever makes it out. And you get a group of, or sorry, you get a cubed root of 3. So as far as our formula is concerned, this is your A and this is your B because of those cubed roots. Again, the formula says A cubed plus B cubed. We figured out we had a something cubed minus something cubed, so this is A and this is B. All that means is you're going to plug it into your formula. Oh my goodness, look at that big gash. Okay, I'm going to write the A and B formulas, and then I'm going to replace all the A's with X and the B's with 3. So it's got a binomial with an A and a B in it, and then a trinomial, and inside is A squared, AB, and B squared. And then if I remember SOAP, my signs are going to look like this. Same as the beginning, which was minus. Opposite sign goes there, always positive there. All right, let's plug in our actual numbers. Let's plug in the A and B. Instead of A, I'm going to put an X. So this becomes an X. This becomes an X. This is an X. And that's all the A's. Okay, in place of B, it's going to be a 3. So I've got a 3 here, a 3 here, and a 3 here. And put a times there just so you can see the little bit that's missing there. Okay, also though, we've got a squared and a squared. So this is squared, and that is squared right there. Okay, I'm going to put my signs in now. This one was the same. Opposite, always positive. And then, of course, we have these parentheses going on to hold all the pieces together. So all I did was replace the A's and B's with their values. If you can get the formula in there, then everything else follows suit. So final answer would be X minus 3 in a binomial, 2 terms. In the trinomial is X squared plus, now X times 3, we don't write it X.3, X times 3, right? We write it as 3X plus, and then we've got 3 squared, which is 9. And that has been factored. So I wrote down a lot of work for this one, but all I'm really looking for as far as work is concerned is this little stuff over here on this left side, the green stuff basically, with all the different rainbow colors in there. Okay, let's try this next one. So I'm looking at this one, looking for GCF first. If you look at these two terms, 16y cubed, 16 is 4 2's, and then 3 y's. 2 is just a 2. Looks like they've got a GCF of 2. So I'm going to pull the GCF out first. Left over is 8y cubed minus, now what happens when everybody disappears? Dun, dun, dun. Here comes the superhero 1. He steps in to save that place. All right, now looking at these two terms, there's a minus in between, so it could be difference of squares, but 8 is not a perfect square, so I'm going to say no to that. Then I'm going to look for perfect cubes. So is there a cubed root of 8y cubed? Well, up here we already had it factored out, right? Cubed root of 8, which is 2, 2, 2. Y cubed is y, y, y. We got a pair of homies. A 2 would make it out. Pair of homies. See? A y would make it out. So it looks like this, the cubed root, is a 2y. Now what about 1? Is there a cubed root of 1? Yeah, it's 1. Any root of 1 is 1. So this right here is going to be my A, and this will be the B.